or review? Solve systems of equations, okay? So you had to solve things like this right here, right? So a 2x2 system there and a 3x3 system. Learned how to do those in 1010. Hopefully that was just a good reminder because we're going to learn how to solve those using a different technique. In fact, we're going to learn how to solve those types of problems several different ways in this chapter. So I want to look at that starter question right there. It says if 2x plus 4y plus 5z equals 7, does negative 6x minus 12y minus 15z equal negative 21? And your options are yes, no, and maybe. So, if this is true, in other words, is this also true? If I'm telling you that this right here is true, is that true? Yes, no, or maybe? The answer there is yes. Okay, absolutely yes it is. Can somebody tell me why? John?
The second one's just the first one all multiplied by -3.
Okay, and one of the first rules that you learned in algebra was if you've got an equation, as long as you do the same thing to both sides, you're going to get another true equation. So if this is true, if we multiply both sides by -3 here, multiply both sides by -3, as long as we did that correctly, distributed through and all that sort of stuff, if that one's true, then that one's got to be true. Okay, because we did the same thing to both sides. Okay, so let's review a couple of those ideas, just make sure everybody's on the same page, reviewing 8.1 and some of those ideas that you talked about in 1010. In 1010, you learned how to solve a 2x2 system. What is a 2x2 system? I've got some blanks here. A 2x2 system has blank equations and blank unknowns. Or in other words, if we say unknowns, we also mean variables. What does it have if we've got a 2x2 system? Two equations and two unknowns. That's why we call it a 2x2. So it's got two equations and two unknowns. There's an example of a 2x2 system right down here at the bottom of the page. Okay? So x minus 2y equals 2 and 3x minus 5y equals 9. That's a 2x2 system. Okay? Now, when we solve a 2x2 system, we're looking for one of these cases right here. And if we say it's got a solution, usually we like it when it happens like this right here. We're looking for the point where the lines cross, right? So we're looking for the point where the lines cross, or where they intersect. So this point right here is the solution to that system. It's the point where that equation is exactly the same as that equation. Okay, now the thing that's hard about graphing these and seeing where the lines cross, I mean, visually it makes sense, but it's kind of a pain in the butt because you've got to have graph paper, you've got to do it perfectly in order to make that work. Okay, so there's the solution to that system. What about this one right here? Does that have a solution? Okay, if we're trying to find the point where the lines cross, they don't cross if they're parallel, so that would have no solution. And what about this one right here? I don't know if you can tell the difference on this one. We've got a blue line and a red line, and that one's kind of purple. What does that mean? They're right on top of each other. Okay, so this one has one solution. This one has no solutions. This one has infinitely many solutions. Anything that's an answer to one equation will also work as an answer to the other equation. Everybody good there? All remember this? Okay, so let's make sure we're clear on the vocabulary. The word is consistent. Does anybody remember what consistent means? And we can be a little bit informal here. What does the word consistent mean when we talk about systems of equations? Okay, let's put it this way. Has a solution. Has at least one solution. There's got to be an answer. So what does inconsistent mean? Doesn't have a solution, or we can say no solution. Okay, does anybody remember what dependent means? They're the same line, so it would be this case right here. So it's going to have infinitely many solutions. And what about independent? This would be inconsistent. That one would be inconsistent. Okay? Does this one have an answer? Has a ton of them, right? Okay? So the word we'd use for this is it's consistent because it has a solution, and we'd say that it's dependent. So this one is consistent and dependent. So guess what this is? This one is consistent and independent. Now, independent means it's going to have how many answers? One solution. Okay. Good there? Any questions? You sure? Okay. So this is what we'd call the Cartesian plane or the rectangular plane. We've got two equations, two unknowns. We can graph that on a two-dimensional plane. Well, when we solve a 3x3 system, you might remember this diagram from 1010. I actually pulled this from the 1010 book. A 3x3 system has how many equations and how many unknowns? 3 equations and 3 unknowns. And when we solve a system, a 3x3 system, we're not trying to find the point where the lines cross. What are we trying to find? Point where the planes cross. Okay? So let's run through and take a look at this example. This one right here is typically what we end up with. Okay? This is most of the time what we're looking for. We hope that we're going to get just one single answer. These 3 different planes cross in that one single point. We've got one right here, one right there, and then that one running sideways. Okay, what about this right here? It crosses in lots of places. Okay, so that one's going to have infinitely many solutions on that one. And what about this one? I don't know if you can see this. Let me outline this one. Looks like that. They don't touch at all. Not on this one at all. So what would we have there? Inconsistent. We'd have no solution there. And how about this one? Well, we've got this line up here where the 2 of those cross, this one here where the 2 of those cross, and this one right here where the 2 of those cross. Remember, we're trying to find the point where all 3 planes cross. They don't. So there'd be no solution to that one either. That would be inconsistent as well. Okay? Now, luckily, you don't have to graph anything in 3 dimensions or anything like that. So we're good there. We just need to be aware that that's really what we're looking for. Okay, if we were to graph these, we're looking for the point where the planes cross. We've got some nice algebraic techniques that make finding the solutions to systems of equations a little bit easier. So I'm going to go through and solve this one. Hopefully you haven't worked ahead on this one. Everybody watch. Okay, I'm going to solve this one in a little bit of a weird way. Okay, I think everybody here could solve this. We've got 2 techniques. One of them is substitution. What's the other way? Elimination. I'm going to solve this one using elimination. One of the things that typically makes this more difficult is people can be really disorganized and everything. So I'm going to try and organize this a little bit more than what we typically would. So I'm going to take this one right here, and I'm going to use elimination, but I'm going to do it in a little bit of a weird way. So you don't necessarily have to write this down. If you just want to watch, that's okay too. So what variable would be the... Now everybody likes elimination, right? That's probably your favorite. Substitution can be a little bit of a pain. I mean, you have to know how to do substitution. You can't get away without knowing that. Okay? So what variable would I want to eliminate here? The x. And which one would I want to get rid of? Do I want to get rid of this one on the top or this one on the bottom? I want to get rid of this guy? Okay, I kind of want to use this one to get rid of the 3x, right? Isn't that right? So what I'm going to do is I'm going to multiply this one by -3. So that's going to give me, let's see, -3x. That's going to give me plus 6y. And that's going to give me -6. Is that right? Okay, now again, if you just watch, I'm going to do this in kind of a weird fashion. I kind of like this guy right here. So I'm going to write down 1x minus 2y equals 2. I was totally okay with that because that's just a 1x, right? If I add the 2 of these together, that makes a new equation. So if this is a true equation and that's a true equation, just like we were talking about before, I can combine those together, I can add them together, and I get another true equation. How many x's do I have in that equation? None, right? I eliminated that. So what I'm going to do is I'm going to put those together. Now this is going to seem a little bit silly. Why would I write that? You'll see why in a bit. Okay? If I put the 2 of these together, how many y's do I get? 1. And is it positive or negative? It's positive. Okay? And then I put these together and I get a 3, right? Is that okay? Maybe more work writing this down than you'd normally do, but this is okay, isn't it? Okay. Now, you can actually look at this and you can read off one of the answers, right? Okay, what's one of the answers? Y equals 3, okay? Now, what I'd like to have is I'd like to get rid of this right here. I'd like to eliminate that Y. I want to figure out what X is. I know what Y is. I want to figure out what X is. Now, I realize you could do this by substitution, but we really liked elimination when you were taking 10-10. I mean, that was pretty much everybody's favorite. So what I'm going to do is I'm going to look at this for just a second, and I'm going to say, what would I add to negative 2y to make it a 0? How could I eliminate that negative 2y? Add a 2. Add a 2y, right? So what if I took this equation right here and I multiplied it by 2? Is that okay? So if I did that, I'd get, well, what's 2 times 0? I'd get 0. So this is 0 x's. Multiply these together, I get 2y. And multiply these together, I get 6. Now, if this was a true equation, isn't that a true equation also? Okay. You with me so far? Okay, now watch. I kind of liked this one right here. So I'm going to write 0x plus 1y equals 3. And now I'm going to make that other equation that I've got right here. What's 0x plus 1x? 1x. Okay. What's negative 2y minus, or sorry, negative 2y minus 2y? 0 y's. And then put these together and I get 8. Now at this point you can read off the answer, can't you? Okay, what do you get? X equals 8 and y equals 3. Or remember, to emphasize that this is the point where the lines cross, this is going to be 8 comma 3, and there's the solution. Okay, are there any questions there? Who thinks that's a silly way to do that problem? Very good, thank you very much. That was my goal. Okay, I'm going to solve this next one the way you would typically do this, but let me show you why keeping things in a nice, neat, organized fashion with a 3x3 is kind of tough to do. Okay, so what variable do you think we ought to eliminate here? Which one would be the easiest to get rid of? Should we? Because what we've got to do is we've got to get rid of either an x or y or z, make another 2x2 system, and then get rid of one of those variables and kind of whittle it down until we've got one variable left. John, which one do you want to do?
Probably X.
Okay. X is okay. You want to do z? Okay. Why do you want to do z?
Because if you times the top one by 2, you take the second equation and eliminate c that way.
No need to multiply by negatives. Other than if we want to get rid of a z here, we could multiply by 2. If I want to get rid of this one, I need to multiply by negative 3 to make a positive 3. So I don't think there's really one choice that's better than another. I kind of like just working from the front to the end, so I'm going to get rid of the x, okay? So here's what I'm going to do. I'm going to take this one, and I'm going to multiply it by negative 4. Okay, now this I would write down. I'd make sure you can do this by hand. So here's what I'm going to do. I'm going to multiply by negative 4, and I get negative 4x. I get positive 4y. I get positive 4z, and I get positive 16. Now, did I do all the multiplication right? Because that's what's tough about these, is you got all these little arithmetic problems to do. Did I do all of that right? Okay, so then I'm going to go ahead and I'm going to put this and this together, and I'm going to make another equation. So that's going to give me no x's, right? That's going to give me 1y, and it's going to give me, is that a 6z? And then a 20. You okay with that? Okay. Or really, let's just write it this way. Is that okay? I like this one right here because it's got one fewer variables. Okay, now I'm going to come back here. Is everybody okay with the stuff I've written in red? Okay. I'm going to get rid of this now. I used that first equation to turn that one into a 0 to eliminate that x. Now I want to eliminate that x because I've got to make another equation, a separate equation, using two different equations that's got a y and a z in it. So what am I going to multiply this one by? Negative 2. So that's going to be negative 2. This is going to be positive, x. This is going to be positive 2z. And this is going to be positive 8. Is that right? And then I'm going to put this one and this one together. Negative 2x plus 2x, I've got no x's. Well, this is good news right here. Look at this. What's 2y minus 2y? No, whoops, no y's. And then if I put the two of those together, I get minus 1z, and that equals negative 3. Everybody good there? Okay. So I'm going to write that over here. I'm going to take this blue equation, and I'm going to write negative z equals negative 3. Okay, now let's think for just a second. I had 3 equations and 3 unknowns. By going through and eliminating, I happen to produce one equation that only has one variable. So, you mean multiply both sides by a negative? Sure, we can do that. So you know what z is, right? Okay, what do you do once you have that?
Plug it in.
Where do we plug it in?
And for that Z, that little one.
Okay, this one right here, in the little one, in the one that only has 2 variables in it, right? So if I put that right here, remember, I can solve an equation that has one variable. If it's got more than one variable, then I'm stuck. So here's what I get. I get y plus, this is going to be 18 equals 20. So I get y equals 2. What do I do with that? Plug both of them in where, Christopher? One of the bigger ones. One of those original ones that has all 3 variables. Now, of equation number 1, 2, or 3, which one should I plug it into and why? Probably 1. Why? It's just simpler. It's got smaller numbers in it. Yeah, it's got quite a few negatives, but as long as we're careful, we should get this right. So this is going to be x minus 2 minus 3 equals negative 4. So this is x minus 5 equals negative 4. So x equals 1. And the answer is? Write it down as an ordered triple. 1, 2, 3. Okay? Any questions? Okay. So, no, it should be okay. One of the things that makes this difficult, now you'll notice how much writing I did on both of these. Okay, and this was a relatively simple 3x3. What makes solving a 3x3 difficult is keeping everything straight. It can be pretty tedious. There's a lot of arithmetic. You've got to keep the x's and y's straight and all that sort of stuff. Okay, so when mathematicians run into something like this, they like to keep things nice and neat and arranged, and we've got a tool that can help us keep things nice and neat and arranged. Okay, and it's called a matrix. So this section and the next couple sections, we're going to learn about matrices. Tylin, what are you doing? Putting that away. Thank you very much. Okay. We're going to learn about matrices and several different ways that we can use them to help us solve fairly complicated problems. Problems that would kind of bog us down mentally if we had to keep track of all the details ourselves. Okay. So we'll kind of compartmentalize and relieve our mind of keeping track of everything all at once. And we'll just focus on a few things at one particular time. So the first thing we're going to talk about is a definition for a matrix. So a matrix is, does anybody know? It is a rectangular array of numbers, and it consists of rows and columns. Now the word array is short for, anybody want to take a guess? Arrangement, okay? So when we say it's an array, what we mean is it's an arrangement. So it's an arrangement of numbers. We're going to organize and arrange the numbers in a rectangle. It'll consist of rows and columns. Okay? The dimensions of a matrix are the number of rows by the number of columns. Okay? It is always rows first and then columns second. Okay? Please don't make up your own, vocabulary or system and say, hey, I'm always going to say columns first and then rows. It's always rows. Okay, like the lines and rows on a paper, and then columns, okay, vertically, okay? The elements or entries in a matrix, they're the individual numbers in that rectangular arrangement, okay? And the indices are the subscripts that indicate the position of an entry in the matrix. In other words, those subscripts or the indices will tell you where that particular entry is, okay? So a little bit of vocabulary there. Matrix, dimensions of a matrix, entries and indices. So if you'll flip the page over. So this second example right here, it says identify the dimensions of each matrix and the A21 entry. Now, just a little bit of convention here. Normally, we represent matrices with capital letters at the beginning of the alphabet. Okay? So you're used to X, Y, and Z being variables. If I say A, B, and C, and they're lowercase, those are usually just numbers. They're constants. Okay? If we use a capital letter toward the beginning of the alphabet, usually it's indicating something that's, not just a regular number. It'll be something like a matrix. Yeah.
Why did you say A21, not A21?
Because it'll make a huge difference. Because these are the indices. Those are those subscripts we were talking about.
That's the row and that's the column.
Very good. So if we identify the dimensions, so let's look at this one right here. The dimensions are the number of, which one comes first? Rows by the number of columns. So how many rows does this have? 2 rows by how many columns?
1,
3 columns. So this is called a 2 by 3 matrix. Let's look at this one right here. Again, always rows first, then columns. 3 rows by how many columns? 3 columns. Okay? How many rows? 1 row. 3 columns. Is that right? Don't get tripped up. It's always rows first. So 1, 2, 3 rows. So this is a 3 by 1. Okay? This is what we call a column matrix. And what about the dimensions on this matrix here?
That's a 1 by 3.
1 row, 3 columns. So we call this a row matrix.
So there was no A21.
Oh, we're not done yet. Okay. So those are the dimensions of each one of those matrices. This is called a column matrix. This is called a row matrix. You'll notice the rectangular arrangement in each case, and we normally put it in the square brackets. Okay. So the bigger the matrix, the bigger those square brackets are going to have to be. Okay. Now, again, by convention, we usually use capital letters at the beginning of the alphabet. So for these purposes, each one of these are going to be called the matrix A. And what we want to identify is what is A21 on this particular matrix. So that means what entry, okay, what number is in that position. And the position is second row, first column. So what is it here? -3. So this is a 2 by 3 matrix. And the element that's in the position 2-1, or the A21 position, is -3.
What if it doesn't have an A?
You're getting way too far ahead. Okay. What about this one right here? What's in the second row, first position on this one?
4.
This one would be a 4. Second row, first position here? 16.
It doesn't have one.
Doesn't have a second row. So A21 does not exist. Okay, do you want it to stay that easy?
Yes, please.
Okay, see what I can do about that, but it's going to get slightly more difficult. Okay, let's take a look at example 3. Okay, this one says, given that system of equations, find what we call the coefficient matrix and the answer column matrix. So, I want to make a matrix, a rectangular arrangement of just the coefficients. Coefficients are the numbers that go in front of the variables, right? So that's a 1, that's a -1, and that's a -1, right? So the first row is going to be 1, -1, -1. Okay, again, why do we leave off the -4 at the end here?
Because we don't care about answer.
Why don't we care?
Because it's an answer, not a
It's an answer, it's not a coefficient, right? The next row is going to be 4, -3, 2. Now, notice that I didn't write the plus sign in front of it. Okay? Not required, because we know that's going to be in the second row, third position. If it doesn't have a sign in front of it, we get to assume it's positive. And then the last row, third row, is going to be 2, -2, -3. And to make sure everybody understands this is a matrix, what do we put around it? Square brackets. So I do square bracket here, square bracket here. Okay, that's what's called the coefficient matrix. Now, if we want to write down the answer column matrix, I've only got these 3 answers right here. They're arranged in a column, so I'm going to write down -4 for the first row, 4 for the second row, and -11. Put square brackets around it. Here's our coefficient matrix. Here's our answer column matrix. Okay. Any questions there? Okay, so now we're going to deal with what we're going to spend most of our time talking about, and that's an augmented matrix. An augmented matrix is, does anybody know what it means when we augment something? Yeah.
You improve it, make it better.
Improve it, make it better, or you at least add something to it. So what we're going to do is we're going to take the coefficient matrix and we're going to slap that column matrix on the end. So here's the augmented matrix that represents this system. 1, -1, -1, and -4. The next row is going to be 4, -3, 2.
So they just are combined.
Basically,
That's easy.
it is easy. Basically, we just combine them. We augment.
That's as hard as it gets.
Good luck. Okay. We augment the coefficient matrix with the answer matrix, and usually we put a little dotted line right here. Sometimes it's a solid line, doesn't really make any difference. And all we're doing there is we're just making a differentiation between the fact that these are coefficients and these are answers. This literally represents this system of equations up here, because this is like the x column, this is like the y column, this is the z column, and that's the answer column. In fact, if you wanted to go directly from here to here, that's usually what we do. Okay? Just start writing them down. And I usually double check that I've written it down correctly. If I wrote them down in rows, I check them by checking the columns. So let's just check and make sure. Does the first column equal 1, 4, 2?
Yeah.
It does. We got it right. Okay? Does the third column equal -1, 2, -3? It does. Any questions? Okay. Can you see how this would be an organized way to keep track of this stuff without writing down x's, y's, and z's? X's are always here, y's are always here, z's are always here. Answers are always at the end. Any questions? Okay. So we're going to learn how to play a sick mathematical game. There we go. Okay. So this game has 3 rules, and if you learn how to play this game, if you learn how to play this game the right way, you can solve a system of equations, a 3x3, a 4x4, a 5x5, whatever it is, using these exact same rules. Okay? Now there's a little bit of arithmetic involved and stuff like that, but you can solve a system of equations without keeping track of which is the x, which is the y, and which is the z. The matrix and that arrangement does that for you. Okay? So here are the rules. Okay? And we call these row operations, and it's a branch of what we call linear algebra. So if any of you turn out to be an engineer or something, you'll take a course in linear algebra where pretty much you just learn how to work with matrices. Much more complicated stuff than what we're going to deal with here, but at least you'll have the basics. So the rules are this. When you're working with an augmented matrix, you can do 3 things that are legal. Okay? Interchange any 2 rows. Okay? We could call that swapping some rows. You can just move the rows around. It's not going to change the answer at all. Replace a row by a non-zero multiple of that row. In other words, times a row by a number. Okay? Remember this example up here? If I take that row and multiply the whole thing by -3, do I get another row that's true? Another equation that's true? I do. Okay? So that's an example of that rule right there. And the third one is replace a row by the sum of that row and a constant multiple of another row. In other words, we're going to times a row and add it to another row. Okay? Okay, again, these are called row operations. Okay? So we're going to start out with a couple of simple examples. They're going to tell you exactly what you need to do. Okay? And you want to do it in this order. So we're going to take this matrix, this augmented matrix, and here's what this means. Row 2 is going to be equal to -2 times row 1, and then add it to row 2. So we're going to take row 1, multiply it by -2, and add it to row 2. Row 2 is the one that gets changed. Let's see. Take a look at this. I'm going to take the first row, and I'm going to multiply it by what? -2. So that's going to be -2. -2 times -3, so that's going to be a 6, and that's going to be a 6. And what am I supposed to do with these guys right here? Okay, add them to what? Okay, I'm supposed to take, whoops, let me change colors here. I'm supposed to take that one and add them together. So this is going to be 0, this is going to be 1, and this is going to be 2. Is that okay? Did it say do anything with row 1? Are we changing that? Nope. We used it. We used a multiple of it to change the other row, but row 1 stays the same. So 1, -3, and -3.
That's our answer?
That is your answer.
Oh my gosh.
Okay.
That's easy too.
We are happy that you're so happy. Any questions? Okay, so let's take a look at the next one. Let me zoom in on this one here. Here's what we want to do. Step A, then step B in order. Okay, now remember, it's the second one that gets changed. I want you to watch something, eyes up here, please. Notice that row 2 equals 4 times row 1, and then we add it to row 2. See how that starts with row 2 and ends with row 2? That's the one that gets changed. Row 3 is going to be 3 times row 1 and add it to row 3. Row 3 is the one that gets changed. I'm going to do this in colors here, so I'm going to do the first one in blue. Yeah. What? Okay. So I'm going to take row 1 and do what with it?
Times it by 4.
So that's going to give me 4, -12, 12, and what do we get here? -20. What am I supposed to do with it?
Add it to row 2.
Add it to row 2. So that's going to be 0, -17, 9, and -25. Is that right? Okay. Okay, now while I'm here, do either one of these permanently change row 1?
No.
No. So I'm going to write row 1 again. 1, -3, 3, and -5. Everybody okay so far? Can I erase this work right here? Maybe I won't. Okay. You don't have the luxury unless you're, and I wouldn't do this anyway. I wouldn't erase your work, maybe cross it out or something, but I'm going to take this one and I'm going to do this command. So this is 3 times row 1, and then add it to row 3. Yeah.
Oh, okay. This isn't A and B, is it 2 different things?
They're 2 separate steps.
They're 2 separate steps. Okay.
2 separate steps. So this is multiply the first one by 3. So that's going to be 3, -9, 9, and -15. And what did it say we needed to do once we multiplied row 1 by 3? Add it to row 3. So I'm going to put that one and that one together. And I get 0, -11, 13, and -9. That's the answer. Okay, they're just getting you used to doing a couple of row operations. You have several problems where they tell you exactly what they want you to do. You have some problems where they ask you to figure out what are the dimensions, maybe write down an augmented matrix or something like that. Okay, are there any questions? Okay, so we're going to go ahead and we're going to solve that system right here using row operations. So a couple of things that you ought to keep in mind to reduce the frustration level. Okay, this can be frustrating because it's a little bit on the tedious side and there's a lot of arithmetic. With a 2 by 2, it's not bad. Okay, but with a 3 by 3, it gets pretty complicated. First thing is go slow. Make sure at every step you haven't made a silly multiplication error. You haven't multiplied 2 negatives and gotten a negative. Okay, done something silly like that. Keep things neat and aligned. Okay, make sure there's the same amount of space in between each column, whether they're positive or negative or whatever it happens to be. Okay, avoid fractions where possible. Okay, and then I'm going to have to explain these next 2 steps. Go column by column. So column by column, getting a 1 first and then using the ones to make a 0. And I'll explain what I mean by that in this step right here. Get the goals in order. So I want you to take a look at the bottom of this page. And we're actually going to look at this backwards. Okay, look at this one right here. if this was the X column, this was the Y column, this was the Z column, and that's the answer column.
We don't know the answers.
Well, let's look at this last equation right here. How many X's?
1, 0,
No X's, right? How many Y's?
0.
How many Z's?
They all equal 1.
No. There's one Z, and what does it equal?
1. C.
It equals C. Okay? Let's look at this row right here.
1 equals B.
No X's, no Z's, but you've got one Y, and what does it equal? It equals B. What does X equal? X equals A. So you can look at this and you can read off the answer. Let's look at this one right here.
Same thing.
No X's, one Y equals B, so Y equals B, and X equals A. Okay? This is called reduced row echelon form. Now, the reason reduced row echelon form is nice, even though it's a complete mouthful, is if you get it in this form, if you can see a matrix in this form, you can just read off the answer. Okay, what if this was 7 and this was 3? X is 7 and Y is 3. It's that simple. Okay, these are called row echelon form. Okay, and row echelon form is still pretty nice. Let's take a look at this example right here. How many X's in this row right here? 0. How many Y's? 1. And you can read off what Y is. Y in this case would be B. Okay, can you do the same thing here? No, you can't. But you do know that that would be 1X, 3 Y's, and it would equal A. And then if you knew what that number is, you could solve the rest of it by substitution. Okay? So the goals go like this. You want to get this first, then make that 0, then make that 1, and then make that 0, and you're going to have your answers right here. So the goals would go in this order. Get that first, get that second, do that third, do that fourth. Column by column, get the 1, use the 1 to make the 0. And eventually what we want is a situation like this right here. We want 1s down the diagonals, 0s everywhere else. 2 by 2s are not very hard. There are only 4 goals, 4 steps if you want to think of it that way. 3 by 3s get a little more complicated. Okay, any questions before I start doing this one? Okay, all right. Let's write down the augmented matrix. 1, -2, 2, 3, -5, 9.
There's your answer.
We'll get there. Okay, what's goal number 1? Get the 1. Get the 1 right here, right in that first row, first column.
It's already there.
Already there. Step number 1's done for us. What's goal number 2?
It's 0.
Turn that into a 0. So let me say this again. I'll say this all the time. Use the 1 to make the 0. So I want to use that 1 to turn the 3 into a 0, and here are the rules I can use. I can, whoops, there we go. I can switch rows. I can multiply a row by something, or I can times a row and add it to another row. That's what I do almost all the time. So use that 1 to make that a 0. What would I add to 3 to make it a 0? -3. So what am I going to do? Okay, let's use this syntax right here. I'm going to multiply row 1 by -3, and I'm going to add it to row 2. Is that okay? Please write down your steps. It will help you in thinking through, and if you make a mistake, it's a lot easier to go back and find out where that mistake was. Okay? It's kind of a pain in the butt when you have to start from scratch. So I'm going to write that step in red. So I multiply by -3, and I get -3. I get +6, and I get -6. Now, does this change row 1 at all? It doesn't. I like row 1. It had that 1 where we wanted it. When I put these together, I get 0, I get 1, and I get 3. Goal number 1. Goal number 2. What was goal number 3? Turn that into a 1, because we want to get the 1s down the diagonals and work column by column and then use the 1s to make the 0s. So, I only have one step left. And what is that one step?
Get that to a 0.
Turn the -2 into a 0. So let's write down what that would be. I'm going to use that 1 to make that a 0. So I'm going to take row 2, and what am I going to do with it?
Times it by -2.
Times it by +2 and add it to row 1.
Where is the negative then? I can see it.
We have a visitor today, and I think she's figured out you're the verbal one in class.
I am so sorry.
Okay. So this is 0, 2, and 6. Now, does that change row 2 at all? No, we like row 2 the way it is. And let's see what we get here. So we've got 0, 1, and 3. We like that. And then I get, okay, now notice this. This is really important. If I add 0 to that one right here, does it screw up the one that we got? It doesn't mess up our goal. It leaves it alone. That's why it's important to go row by row, get the 1, and use the 1s to make the 0s. 2 plus -2, 0. And then what do I get here? I get, yep, 8. So you got to be careful with that arithmetic. Okay, now, that's the answer. This is in reduced row echelon form, so you can just read off the answer. What does that first row mean? It means there's an x, it means there's no y's, and it equals 8. So it means x equals 8. That second row literally means there are no x's, there's a y, and it's equal to 3. So the answer is 8, 3.
Can we just write the answer as x equals 8, y equals 3? Do we have to write it like we just did?
Usually you write it as an ordered pair. Okay. If it were somebody other than you, I'd be a little lenient.
Whatever.
Okay. Any questions? Sure? Okay. All right, let's look at this one right here. Okay, write down the augmented matrix. 1, -1, -1, -4. It is, so we should know what the answer is, and we'll know if we screwed this up.
I say we just cheat.
Okay, how many goals do we have here on a 3x3? You have 9. Okay, everybody watch, please. Okay, you're going to get that one first. Okay, so here's goal number 1. So you're going to do this first. Use that 1 to make these 0s. First, second, and third. What about this second column? What do you do first? What's our 4th goal? The middle, it's the 1. You use the 1 to make the 0s. So this is going to be 4th. 5th and 6th doesn't matter. Okay, you can put them in either order. Okay, what's our 7th goal? Get the 1 here. So there's 7th, 8th, and 9th. Any questions? Okay, what's goal number 1? Get the 1. Done for us. 8 more steps to go. Okay, what are we going to do first? Turn what into a 0? Turn the 4 into a 0. How am I going to do that? Okay, so I'm going to take row 1, I'm going to multiply it by -4, and I'm going to add it to row 2. So that's going to be -4, +4, +4, and +16. Now, does that mess up row 1?
No.
It doesn't. I like row 1. I'm just going to write that again right now. And now I'm going to write my new row 2. What's that first element? What's that first entry? 0, just like we want. Next one? Oh, that sounds good. Next one? 6, 20. Okay, now, everybody watch, please. If I do this one step at a time, I have to write down 7, 8, 9 augmented matrices. Would it be okay with you if we got rid of that one in the same step? Since I want to write one that I like right here, can we do that at the same time? Everybody good with that? So what is that step going to be? -2, row 1, add to row 3. And row 3 is the one that's going to change. So that's going to be, if I multiply it by -2, that's going to be -2, 2, 2, and 8.
I thought we wanted to get 1 right. No, I didn't. I was kidding.
Okay, you with me? Okay. All right. Got that written down? Okay, watch. Goal number 1, 2, and 3, all taken care of. We got the 1, we used the 1 to make the zeros. What's our 4th goal? Get the 1 in the middle. We want those 1s down the diagonals. Now, I've got the 1, so that's goal number 4. What's 5 and 6? Get a 0 here. So I've got 5 taken care of. What's goal number 6? Turn that one into a 0. How do I do that? Write it down. Write down what you think you'd do. I'm going to use row 2 to turn that into a 0. So really what I'm going to do is I'm essentially going to multiply it by a 1 and add it to row 1.
I thought we were using row 3.
Nope. Use the 1 to make the zeros. We're working on column 2 right now. So we'll be using the 2nd row.
Okay.
You with me? Okay. Once you get to that point, you are 3 steps away from being done. Our time is up for today, but what I want you to do is I want you to stop right there, and if you can finish it, I'm going to pick up right there tomorrow on maybe on a separate piece of paper. Try to finish that, and then tomorrow we're just going to do a bunch of those, practice that, and then we'll be done with 8.2 and we'll move on. Okay? Again, please make sure I've got your test before you leave. If you want to go over that, stop by sometime. We'll pull that out and take a look at it.